All right, so the probability review. This one is geometric, and I'm not going to ask a question anything like this, but what we're looking at, I don't want to look at less than 5. Now, the answer for this one and the way it's set up, this is a geometric CDF, because it could be 0, 1, 2, 3, or 4 cars. It can't be 0 cars. So we would find it on the calculator where P is 0.4 and our number of trials for X is going to be 4 because it's CDF. It's covering 1, 2, 3, or 4 cars. So it would be 0.4 and 4, and that answer is 0.8704. I'm not going to worry about that. I'm going to show you that. What we will be on the test is this expected value of X, since it is geometric. The mean for geometric is 1 over P, so that makes that 1 over 0.4, which is 2.5 cars. So that'd be 2.5 before they saw a white one. Okay, then on this one, to determine the probability of a random card, well, this is 6,010 cars. Okay, out of 6,010 cards, they give 100. That's out of every 100,000. They expect this many winners. So that's simply 6010 over 100,000. Which you move your decimal because of the 5 zeros. Move this 5 places, which is answer B. Number 4, the expected payoff per card, $0 for 93.99% of the people, $5 per 0.05 of the people, $50 for 0.01. Sorry, I put a decimal in the wrong place on that one. And then 1,000 for 0.001. That's 5,000 out of 100,000, 1,000 out of 100,000, and 10 out of 100,000. And then we simply add those values together, and that equals 0.85. So 85 cents per play. Now, what they don't tell you on that, that's the expected payoff per card. Okay, what they don't tell you is you're spending $2 for the ticket. So if you think about it, $2 minus 85 cents, you're losing every time you play $1.15 on average is what you would expect. Okay, so let's look at this one. Chances of winning are 0.2, so P is 0.2. That means losing is 0.8. And if you play it 5 times and they're independent, what's the probability that you win at least once? Okay, at least. At least means we need to do what? It means we need to look at the complement. So it's going to be one of these two. Okay, so that you win at least once. The opposite of that is losing every time. The opposite of that is losing every time, which is 0.8. So this would be our answer. We would say, okay, what if we lost every time? 0.8 to the 5th, and then subtract that from 1 to get our complement. Okay, so this one, a random student at River City High School is chosen. And so M and F and ate breakfast, did not eat breakfast, and there's our probability. So given that a student, oops, let me slide this up a little bit. Given that a student ate breakfast is selected, so here we go. Ate breakfast here is 0.32 because we multiply. Breakfast here is 0.18. So that's our total. So what is that combined? That's 0.5. What's the probability that he is male? Okay, given that they ate breakfast. So it's 0.32 given that they were male and ate breakfast. Out of the total that ate breakfast, which was 0.50, and so what is that value? Well, double that. And the answer, this is 0.64. But I look down here and it's not there, but when I turn over to the top of the other page, there it is, D, 0.64. Okay, what is the probability that a student selected as male and ate breakfast? Male and ate breakfast, it's 0.32. What's the probability the student had breakfast? Okay, that's 0.5. That's what we already determined here. This is all those that ate breakfast. And we could set up a thousands table with this if you'd prefer and work from there, but hopefully that makes sense to you. So that's 50%. Okay, airplane had a front and rear door that are both open to allow passengers to exit when the plane lands. Plane has 100 passengers seated. The number exiting through the front door should have. Who knows? It's not binomial, nor is it geometric. We don't know how many go out the front, how many go out the back. That's a horrible question. The answer is E, none of the above. Well, I don't like that at all. Okay, here's an assignment of the probabilities face that comes up when rolling the dice once. Let's see. 1 and 2 make 3, make 6 and make 7. All of these added together, all 6 of those numbers added together, it doesn't say it's a fair dice. It says when rolling a dice. Okay, 3 and 5 may or may not, may have a smaller face, there's something to it where they don't work. As long as my probabilities add up to equal 1, that is a legitimate assignment of probability. That's legal. As long as these numbers add up to 1, that is a legitimate assignment. Does that make sense? They equal 1, the probabilities do, so that has to be a true statement. Mr. Oakley, does that make sense?
Yes, sir.
As long as it doesn't, most people would say no because of the 1/6. It doesn't matter. It doesn't matter. Okay, so, whoops, wrong place. Number 11. Oh, good, give us a table. Lord mercy, we need a table. Simplistic. Okay, probability they have a cat or dog or both at home. Oh, it's out of 100, so this should be fairly easy. If a single student is selected at random, and you know that she has a dog, what is the probability she also has a cat? That's 12 out of 16. So it's a probability of cat given they have a dog. So that's going to be 12 out of 16, also known as 0.75, 3/4. If a single student is selected at random, what's the probability associated with the union of events has a dog and does not have a cat? Has a dog, does not have a cat. I'm not agreeing with that. What's the probability associated with the union of the events has a dog and does not have a cat? Oh, does not have a cat. So that's this and this. Boy, I don't agree with their answer at all. They say that's 0.9. That can't be right. Has a dog, yes, and does not have a cat. Oh, they multiplied this and this together. Ooh. Or added, excuse me. They added those two together and called it this. That's all the possible outcomes that could occur with the two. Okay. So that's 16 plus 78. Horrible question. I've never seen one like that before. Out of 100. So that's 90 out of 100 or 90%. Yuck question. Don't like that at all. Okay, if two students are selected at random, what's the probability that neither of them has a cat or a dog or a cat, sorry. Okay. So two students selected at random. So the first student, probability of the first student has neither a dog nor a cat. Neither is 74 out of 100. And then again, that has neither one is, and it's two are selected at random, so we're going to say 0.74 and then times 0.74. This doesn't have either one. And so if I multiply those two together, I get 5.5476, which they rounded to 0.548. Okay, question 14. A survey asked a random sample of 1,500 adults in Ohio. They support an increase in the sales tax from 5 to 6% with additional revenue going to education. Let X denote the number in the sample that say they support the increase. Suppose that 40% of all adults in Ohio support the increase. What is the mean of X? Okay, so they either do or they don't. This is binomial. So what this is going to look like is simply this times this, 40% of 1,500, which is 600. And then we have to turn the page to find the answers of it. Again, this is simply going to be NP. Sample size, 1,500 is N, 0.4 is P. And that is answer D, 600. Okay, then it wants to know what's the approximate standard deviation. Again, it's binomial, so we look at NPQ. 1,500 times 0.4 times 0.6, and the square root of all that. So let's see. I'm going to suggest that, I bet that's 19. Have you done this, Kidra? Huh? Oh, okay. Times 0.4 times 0.6. The square root of that. Oh, shoot. Hang on. Second square root, second answer, enter. Yeah, 18.97, which they rounded, obviously, to 19, which is fine. That's our closest answer. Okay, a random variable is selected at random. A random variable is, a variable whose value is a numerical outcome associated with a random phenomenon. Okay, this is the important part, the numerical outcome. So that answer is 8. Okay, question 17. So we have babies are independent, probability of a boy and the probability are both 0.5. That makes sense. Two possible outcomes. So P is 0.5 and Q is 0.5. I don't know where B just came from. Okay, what's the probability that at least one of the next three boys, there's that phrase, next three babies is a boy? Okay, so it's a boy, not a boy. It is binomial. So we're going to go 1 minus a binomial CDF, that none of them are boys. Well, duh. I mean, think about it, ladies and guys. It's either 0.5 or it's not 0.5. It's the same thing either way, but we'll go ahead and do it this way. So that at least one of, how many babies are being born here? Of the next three babies. Okay, so N equals 3. So I'm going to go 0.5. No. Let me do this correctly. Let's put the binomial second distribution, binomial CDF. Okay, so there's 3 trials. That's 0.5. And then it asks, okay, what is my X value? Well, that at least one is a boy, that means we want that X equals 0, that none of them are boys. So this is going to be 3 things, 0.5 and 0. which is going to be the same either way. So that's going to be 0.875. So in other words, it's 0.5, 0.5, 0.5, because that 3 babies being born, which is 0.125, and then just subtract that from 1. Kind of a silly way to do that. Okay, question 18. A game consists of 3 cards at random from a deck of playing cards. You win $3 for each red card that is drawn. It costs $2 to play. For one play of this game, the sample space S for the net amount you win is... this is the various ways you can win, given you're drawing 3 cards at random. Oh, we'll never be asked this. The answer to that's going to be C, because you could draw all 9 cards are red, which is $3 each, $2 to play. 9 minus 2 is 7. That's the smallest it could be. If none of them are red, which is this, is -2, and these are the portions in between. 18 is not a good question. You won't be asked anything like that, but it was on this page that I picked out of the thin air, so I understand how we get the answer. The possible outcomes are you lose both your $2, you pick 1 red card, which means you make $1. You pick 2 red cards, which means you make $4, or all 3 of them are red, means you've made $7, because you paid $2 to begin with. Okay, let's look over here, and this is going to be our last bit. So in a particular game, a fair die is tossed. If the number of spots show 4 or 5, you win $1. If they show 6, you win $4. If they show 1, 2, or 3, you win nothing. Okay, it's a fair game. So what is the expected value of X? So 1/6 of the time. Okay, so we multiply 1/6 of the time, you win $4. 1 out of 6. 2 out of 6, you win $1, and half the time you win nothing. So multiply this and multiply this, add them together, and you're going to get $1. So that answer is B. Okay, 20 is totally different, doesn't have anything to do. Event of probability A is 0.4, probability B, so the probability of A is 0.4, probability of B is 0.5. They are disjoint. What does disjoint mean? Kedron, what's disjoint mean? They can't occur at the same time. They can't occur at the same time. So what's the probability of 2 things that can occur at the same time? 0. Probability of all disjoint events, also known as mutually exclusive, it ain't possible. It's not happening. Okay, let's look at 21. Does that make sense? Yes, sir. It can occur. All right. Coins are tossed. The probability of getting 2 heads is 0.25. That means, okay, what does that mean? Well, that means you would expect that the more you do it, about 25% of the time, you'll get 2 heads. Okay? They're each independent. The more and more and more we do it, remember if we talk about you cannot say this, exactly 25 of them if we do 100. We don't know. Sometimes, yes, it's probable. It's even possible, but it's not more than likely going to happen. Odds we don't talk about, so we don't worry about that. In the long run, the average number of heads is 0.25. No, that's not what it says. The average number of heads is 0.5. But in the long run, we'd expect about 25% of the time to get heads on each of the 2 coins. Okay, I told you to skip 22. All right, so here, if, excuse me, we're looking at the probability of these 2 events occurring. So what's the overlap of the 2? If they're both independent events. So real quickly, we're going to go A, not A, B, not B, totals. So for A, it's 0.2. This is or we'll say 200 and 800 and 1,000. We'll keep it this way. So that makes this 400, 600, and 1,000. Okay, they're independent, so we multiply 0.2 times 0.4, which is 0.08. So this is 80. Okay, and we're wanting to know what's the probability of both of them of getting this or that. This means or. That means or. So we can add these two together, which is 600, and subtract 80 from it. We're going to get 520 or 0.52, but we can go ahead and fill in the other numbers on this if we want to. This is 120. This is 320. And let's see, what is this number here? 480? Yeah. So we can go 1 minus 480, which is 520, or we can add these three numbers together. That's what this means. This means or, the union of. And I told you not to do these. Okay. Now I'm going to go enough of that because I can only make videos that are so long.